Let us go for balancing of the redox reactions in presence of different mediums like acidic medium as well as basic medium. Here we are having some set of equations which are unbalanced format. Now under given conditions we have to go for balancing of the equations, whereas the mediums required for those balancing of equations are acidic as well as basic medium. Let us go for the equations. Here the equation is provided for us, that is MnO4 minus plus I minus in presence of basic medium has to be converted to the products, that is MnO2 followed by I2. So therefore in this reaction the oxidizing and the reducing agents, that is MnO4 minus is undergoing reduction and it is converted to MnO2. I minus is undergoing oxidation and that is converted to I2. This particular process is happening under basic medium conditions. We have to balance this one by ion electron method. Here the suggested method for us for the balancing is ion electron method. What is the method for us that is given? That is ion electron method. Whereas in doing so, in balancing the equations in terms of ion electron method, we have to divide the equation into two halves. That is, first half is oxidation half reaction, whereas second half is reduction half reaction. This is oxidation half, and this particular portion as being it is a normal redox reaction. This is a reduction half reaction. Whereas oxidation is the part where the losing of electrons. Oxidation meaning is what? Losing of electrons is present. That is electron net loss is observed here. Whereas reduction is gaining of electrons. In terms of electrons, if you talk about the oxidations and the reductions, oxidation is a part where the losing of electrons takes place and the reduction is a part where gaining of electrons takes place. If I look at the oxidation number of central atom, that is MnO4 minus, manganese is present in +7 oxidation state. I is present with -1 in oxidation state. MnO4 manganese is present with +4 oxidation state. I is present with 0 oxidation state. Here oxidation increment in oxidation number. See here I minus is converted to I2. So this is I minus is converted to I2 is a particular part which is a 50%, half of the reaction that is going to be occurring over here. Similarly, reduction is gaining of electrons. Gaining of electrons stands for the change in oxidation number, fall in oxidation number, dip in oxidation number, that is MnO4 minus is converted to MnO2. Whereas to balance these individual halves, that is 50% of oxidation half as well as the reduction half, one thing that we have to do is here law of conservation of central atom has to be maintained. Here our central atom is I, whereas here central atom is what? Manganese. In order to maintain law of conservation of number of central atoms, one I is converted to I2. I2 is a species, I2 is a molecule. So we can't ignore the I2 because I2 can't made into halves, I2 can't made into fractions, I2 is minimum, I2 should be maintained. So therefore this particular one is 2 times of I minus conversion to I2 is going to be taking place. Similarly here MnO4 minus is converted to MnO2. This is law of conservation of central atoms if it is concerned. After conservation of central atom, we have to go for the other atoms. Luckily, in this first half, we can't find any kind of other atoms, only I is present. So therefore, 2I minus is converted to I2 is a balanced part in terms of different atoms are concerned. Similarly, this MnO4 minus is converted to MnO2. Manganese is balanced, one manganese is maintained as one manganese. If I go for the other atoms, the other atom present over here is oxygen. This oxygen is 4 in number, this oxygen is 2 in number, whereas 2 oxygens are less towards the right side. In order to make it balance, I am writing every oxygen atoms is compensated by writing the same many number of water molecule, and it is 2H2O. Whereas if it is 2H2O, now there is a difference in the counting of number of water molecules, number of hydrogen atoms. These hydrogens by number 4, whereas here the number of hydrogens are 0. In order to balance these hydrogens, if it is acidic medium, directly we will write 4H pluses, but it is not the acidic medium, basic medium. As being it is basic medium, Water mathematically becomes equal to H plus followed by OH minus. We need H plus, so therefore this H plus can be written as water minus OH. Whichever side you have to add the H plus ions, to that side the same many number of water molecules, and the opposite side of the arrow mark the same many number of OH minus ions are added. So therefore here lack of 4 H pluses. So therefore 4 H pluses can be written as 4 water. This is 4 water, and this side we have to write it as what? 4 OH minus. So net is nothing but what? 4 H plus ions are added. Hence the net equation is MnO4 minus plus 4 H2O is converted to MnO2 plus 2 H2O followed by what? 4 OH minus. Whereas here unnecessarily here are there some number of atoms are got repeated, whereas this particular portion is not visible. I will write this particular part at this portion where it is going to be appearing visible. If I adding one to the other, this appears as here I am writing a line followed by besides I will write. So therefore this appears as MnO4 minus plus, this one is how much? 4H2O. This is 4H2O. This 4H2O is converted to MnO2. This is MnO2 plus 2H2O followed by 4OH minus. Whereas here repetition of water molecules is present before and after the arrow mark. After eliminating this extra water, the net equation appears as this is MnO4 minus plus 2H2O is converted to MnO2 plus 4OH minus. I am claiming it as equation number 2. I am claiming it as what? Equation number 1. Due to not having of enough space, we will write the equation 1 and equation 2 on the board as a starting part. Then we will extend this one to go for the complete writing of balanced format of the equation. So, and writing at the early part on the board these independent equations, that is 2I minus is converted to I2 as equation number 1. Similarly, MnO4 minus plus 2H2O is converted to MnO2 followed by 4OH minus is equation number 2. Now, after naming the equations as 1 and 2 are very clear in terms of balanced atoms of all, not only the central atom, the other atoms other than central atoms, like whatever is present, that one, especially oxygen is also balanced, hydrogen is also balanced. That is, in terms of number of atoms, the first half reaction is a balanced part, that is oxidation half is a balanced part. Similarly, the reduction part is also what? A balanced part. But now we have to balance in terms of number of electrons, because it is the part where some electrons are lost from the system. This is the part where some electrons are gained from the reactants and it is converted into product. Now, in order to balance these terms, these equations in terms of number of electrons also, we have to take charge into consideration. If I take charge into consideration, 2 anions combination is converted to a neutral species. 2 anions combination is converted to neutral species, and is possible if it is taking 2 electrons only. If it is losing 2 electrons only, then this particular action is going to be existing. I am claiming it as what? 1 star. Claiming it as what? 1 star. Similarly, this is 1 minus plus 0 is converted to minus 4. 1 minus is converted to minus 4. That is possible if it loses 3 electrons, because minus is symbol for electrons charge. Every electron related counteraction is taken into consideration. 1 electron system is converted to 4 electron system is possible by gaining 3 units of electrons, that is 3 unit electrons, that is 3 units of negative charge. So therefore the net charge also taken into account. If charge is taken into account, in terms of charge also the balance is possible if this system is converted to, if it is taking 4 electrons, thus it is converted to where? This particular system. This I am claiming it as complete balanced equation, not only in terms of atoms but also in terms of what? Electrons. Now 1 is balanced in terms of atoms, 1 star is balanced in terms of not only atoms but also in terms of what? Electrons. 2 is balanced in terms of atoms, 2 star is balanced not only in terms of atoms but also in terms of what? Number of electrons. This is in order to maintain law of conservation of electrons. Whatever 1 star is there, Here number of electrons are 3. We are multiplying this one with 3, and whatever 2 star is there, this 2 star number of electrons involved are 2, and we are multiplying with 2. Now here this will becomes net a release of electrons by number 6, and this becomes net gaining of electrons by number 6. To maintain this law of conservation of electrons, vice versa multiplication followed by adding one to the other, this particular equation becomes 3 times multiplication 6i minus is converted to 3i2 followed by 6 electrons. Similarly, if I multiply with 2 MnO4 minus plus 4H2O plus 6 electron system is converted to, this is 2 MnO2 plus followed by 8OH minus. In this case, it is losing 6 electrons. In this case, it is gaining 6 electrons. After adding one to other, it becomes a total conservation of electrons. Whatever lost, whatever gained becomes equal to one another. This net equation becomes 6i minus plus 2 MnO4 plus 4H2O combination is converted to 3I2 followed by 2 MnO2 followed by 8OH minus. This is the complete balanced equation. In this way, an equation is generally balanced. This particular form of equation is the ionic form of balanced equation, whereas if I want to write no charged species, if I want to write the molecular species, on writing the molecular species, it will become the molecular form of the balanced equation. Suppose in order to write the neutral species from the corresponding cations and the anions, if I rewrite this equation, this appears as, and writing on the top, equation appears as like this. This is an anion. If I feel this is countered with the cation like potassium, this is potassium iodide, whereas this molecular species potassium salt, that is KMnO4, becomes neutral, plus this is 4 water molecules combination. Now this is converted as 3 I2s plus 2 MnO2s plus total number of i's, these are 6 plus these are 2, total 8, hence it becomes equal to what, 8 molecules of KMH. In this way, the total net balanced equation is present. The best way of representing the balanced equation, why this particular hierarchy is present, is first of all we have to write the skeletal equation, and we have to remove all the coefficients whatever are present, whatever unnecessary cations, repeating cations in the starting material and the repeating anions in the starting material and the product materials are to be removed. Thereby we will reach to a stage where minimum content is present, where confusion level is decreased to the minimum extent. Thereby we have to identify individually the oxidation part related first half and the reduction related second half of the equation separately. Thereby we have to balance the central atom. By number central atom should becomes same and equal in both the cases. Then we have to go for the other atoms as per the medium is concerned. Then at the end we have to go to the stage where charge is to be balanced, that is electron number is also balanced, and we have to make the equations as balanced counterly by the number of electrons. That is to validate this law of conservation of electrons, vice versa multiplication can be done. Then adding one to the other results into the form of the ionic form of the balanced equation. Then if I want to write the molecular form of the equation without getting confusion, to reduce the confusion to the minimum extent, whatever the charged species are there, charged species are to be written as molecular species, neutral species by the counter ion repetition, both as in the reactant as well as the product. Thus we will be getting the final equation. Thus final equation for the basic medium conversion of potassium iodide reaction with oxidizing agent KMnO4 results oxidation of I minus into I2, whereas this KMnO4 as being it is oxidizing agent undergoes reduction and it is converted to MnO2. In this particular process, 8 units of, if it is 6 molecules, 8 units of potassium hydroxide formation also takes place. If I write in the simplest form, 6I minus plus 2 KMnO4, that is MnO4 minus S plus 4 waters combination results into, that is 3I2 plus 2 MnO2 plus 8OH minus.